Corporate finance practice problem using Excel. Asking the question, how much to invest to reach an investment goal with a standard one-time investment that grows over time versus an annuity type of investment. Get ready, it's time to take your chance with corporate finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet and would like to follow along, we are in the Practice tab down below as opposed to the Example tab. The Example tab, in essence, being an answer key. We have the information on the left-hand side. We're going to put that information into the blue area on the right-hand side, including mathematical calculation. We'll do the Excel formula, present value tables for both an annuity type of calculation and the present value of one, asking the question, how much to invest to reach a goal. So we have the alternatives of putting money in. We're trying to reach a particular goal, that being $30,000 in 10 years. So our goal, we want $30,000 in 10 years. Two options for us to do this. One, let's think about us putting in some lump sum today and then having it accumulate up to that $30,000. How much would we then have to put in at this point to do that? That would be a standard present value type of calculation, which is a little bit might seem a little bit unusual to think of it as a present value because you're thinking about a future value goal. But to get there, the easiest way to figure that is to basically take that future value goal and bring it back to the current point using the current discount rate. So we'll do that. And then we'll consider, well, how much would I have to put in an annuity type of format to reach that same goal? A little bit more difficult of a question. We'll consider that as well. So let's start with our first one here. We're going to invest the 30,000 is our goal, our investment goal. So the years are going to be 10 and the rate is going to be 12%. We are going to have to come up with some type of rate when doing this kind of analysis. That's a projection into the future. So we can take into consideration the opportunity cost or what else we can do with the money and interest and whatnot, inflation in other words, in order to pick that up. Once have that, then we can just simply do a present value calculation to bring it down to the current day, and that'll basically be the investment that would then grow if we went the other direction, right? So that's why it's a present value type of calculation. We have our formula down here. Present value equals the future value times 1 over 1 plus r to the n. We're going to break that out into our table type of format as we have seen in the past. So we're going to say this is going to be equal to the 30,000. Then we got the 1 plus r to the n, which is going to be 1. R is going to be the 12%. We'll percentify that and underline it. Go into the Home tab, Numbers, Percentify, Home tab, Font, Underline, and then we'll add that up, adding it up. I'll use the trusty sum function. The underline's not working properly. Underline's not working. There it goes. Summing this up equals the SUM of those two. That's going to give us, I'm going to percentify this, Home tab, Number, Percentify. And then we'll take it to the number of periods, in this case 10, periods being in years, and pull this out to the outer column. So this is going to be equal to the 112% shift 6 caret, in other words, to the 10. And there's our 3. I'm going to underline the 10, Home tab, Font group, and underline. We're going to add some decimals to the 3, which I call decimalizing it, and the Home tab, Numbers, and decimalize. And then we'll underline that one too, Home tab, Font, and underline. So there we have that. And then we're going to go ahead and divide this out. We got the numerator and the denominator. So the 30 divided by this number we just came to, there it is. Let's add a couple decimals, Home tab, Numbers, couple decimals. And then, so that means that we would have to put in a lump sum 9659.20 in order to reach the 30,000, our goal at the end of the 10 years if we had the rate at the 12%. Let's look at the table amount. If we were to use the tables, how would we calculate the table amount, which we'll see in a future type of calculation? It would be this divided by that. There's the amount on the table. We'll find that down below when we get to the table time, which is it's coming up soon here. So you can look forward to that. It's going to be great. And then now we'll do the present value with the formula. So this is going to be equal to the PV, present value. And then the rate is going to be the 10%, comma. And then the number of periods is going to be 10, comma. It's not an annuity, so we're not going to be using the payment. So I'm just going to put another comma. And then the future value is that 30,000, closing it up, enter. There it is once again. So there it is once again. Let's flip the sign by double clicking on it. going before the p, putting a negative, which in essence multiplies it times -1. There we have it. Let's do the same thing using the tables, table time. And so this is going to be the 30,000. And then we'll go back on over. We're just going to look up on the table periods 10 or 12. So 12% 10 years. 12% 10 years. So here's the 12. Here's the 10. That's going to be 0.3220, 0.3220, 0.3220, 0.3220, 0.3220. Decimalizing it. Home tab numbers decimalized. And then we'll underline home tab font and underline. Multiply it out. That's going to be the 30,000 times that percent. Add a couple decimals. Home tab number couple decimals. And now we have 9,660, which is close to the 9,659.20 we got before, slightly different due to rounding. Tables only taking it out to 4 digits as we see here, as opposed to if we took it out a few more digits, it would be the 0.321973 as we saw calculating it before this. Now let's take a look at our annuity type of question. That's how much we would have to put in to get to 30,000 if we put in one lump sum. But now let's think about an annuity type of situation, bit more complicated of a question, meaning how much would I have to put in terms of an annuity in order to reach that 30,000 at the end of it. So in this question, if we have our formula down here, there's a couple ways we can do it. You could do it algebraically, of course. So we know what the end result would be. We're trying to get to the 30,000. So it would be 30,000 would be equal to P, which would be the unknown. So that would be the unknown. And then times 1 minus 1 plus R, which would be the 12%, to the negative N, which would be 10 years, divided by R, which would be 12%. And then simply solve for P, the unknown, using the algebra. Note that if you're using something like Excel, you're probably not using the formula, you're using a function within Excel. So I'd like to use a tool in Excel to kind of figure out what we might do or how we might look at this as well. Now, when I think about this, we're going to eventually get over here to the present value of an annuity formula and think about how we can use that same formula when we have an unknown that is part of the calculation of that formula, but not the end result that we would typically have. Do we need a whole new formula that we have to use within Excel? We may be able to do that. Or can we use the formula that we know? In other words, when you look at a algebraic problem like this, then any unknown that you have, you don't need to memorize a whole new formula. You just need to find what the unknown is and then use your algebra to solve for that unknown. If I use an Excel function, I don't have the same algebraic equation. I can't work it out algebraically that way, but I can still use the same function if I use like a trial and error or goal seek, which helps us with a trial and error method. So first, let's understand this by breaking this out into our table and doing this in like a trial and error method there, and then we'll apply that concept to the Excel goal seek. So what I'm going to do is the thing we don't know then is P. That's what we don't know. So what I'm going to do is just make up a number so I have something that can be calculated upon, and then we'll adjust that number using the goal seek feature. So I'm going to put the 1,000 here, and that's just going to be a random number that we put in order to work through the practice problem. And then we're going to go through the rest of our calculation, which is going to be 1, and then I'm going to pick up the 1 plus R to the negative N. So I got 1 plus R, which is going to be the 12%. And 12%, percentifying that home tab numbers, percentify, underlining it, home tab font and underline, adding that up with the trusty sum function. Trusty sum. Percentifying that home tab numbers, percentify that one. And then we're going to take this to the negative power of the number of periods, which in this case is years and 10. And then I'm going to pull this out to the outer column. Now let's underline it first. Home tab font, underline, outer column equals the 112% shift 6 caret to the 10. That gives us this. Let's percentify. Home tab numbers percentified. So we have percentified it, and then home tab font and underline. We'll do the subtraction now. This is going to be equal to 1 minus this number. Percentifying that number, home tab numbers and percentify. So there we have that. So that's going to be the numerator, the denominator, then R. So R is on the denominator, the 12%. And percentify that, home tab, numbers, percentify, underline it, home tab, font, underline, bringing that out to the outer column, dividing numerator divided by denominator, numerator over divided by denominator. Then we'll add some decimals here, home tab, numbers, decimalized, and then home tab, font, underline. And then we're going to multiply this out. This is going to be the 1,000. That's the kind of the unknown times this number. And there we have it. Now note this number, we know what it should be. We're trying to get to that 30,000. We're trying to get to this 30,000. So we could, of course, do this algebraically. Go down here and then put in the algebra and solve for P. Or if you have something like this set up, then you can basically use trial and error, right? I could say, okay, well, this needs to go up, right? I mean, maybe if I try like 2,000, then that's getting closer. How about 3,000? And so on. And you can use a method of trial and error that's a lot faster. I mean, Excel already makes it a lot faster by being Excel, having everything connected so we can then back into this number without doing it algebraically, just simply use trial and error. But we can tell Excel to do that as well by going then to the data tab, and then we go to the forecast what if analysis, and we're going to use the trusty goal seek. Goal seek is trusty too. So we're going to then say that this is going to be, I want to set this cell, we want that to be 30,000. I'll put 0.00, 30,000. And we want you to do that by changing this cell. So I'm telling Excel, just do what we're doing, trial and error, till you find what number should be in that cell to make this cell be what we want it to be, 30,000 in our case. So we'll say okay, and it does it, totally does it. So we're going to say okay, and then there it is. I'll add a couple decimals, home tab, and a couple decimals. So there we have it. And sometimes you got to be careful on the rounding here. So sometimes it may not be quite as exact when it does the goal seek, but you can see how you can kind of back into it with that tool. Now, if you have a fairly basic algebraic equation, you might say, why would I do that? Why wouldn't I just do the algebraic equation and solve for the unknown? You can, but oftentimes we don't have the algebraic equation, and many other times when we're using a function in Excel, it might be more complex even than this function, and we might say, I don't want to touch the math, you know. I want to use the function in order to do it, and when I have the function, I can't really use the algebra in that same way, but I can use goal seek in a similar fashion. So for example, this calculation, we're looking for the present value of an annuity. We know what the end result should be. It's going to be that 30,000, but how do I use the function to solve for the unknown when it's not the 30,000 ending result? You can kind of do the similar thing as algebra by using a trial and error method to solve for any other unknown that's in that function, which is a useful tool. So for example, I might estimate once again that the payment's going to be 1,000 here. I'm going to say this is going to be equal to the present value of an annuity. So present value, we're going to pick up the rate, which is going to be then the 12%. I went way too far. 12% here, and then I'm going to say comma, and then the number of periods, which is going to be 10, I think it was. Yeah, 10. I was right. 10, and then comma, and then we're going to pick up the payment, which is the unknown. So I want to pick up something there, because if I just put 0 in there, then it might, sometimes a 0 will mess up an equation if it's in like the numerator or denominator. So you don't want the 0 there. Typically I want some number there, and I want it to be designated in some other cell so that I can tell the goal seek, look at that cell and change what's in that cell to get to the answer. So we're going to say, okay, I'm going to make it a positive number by double clicking on it, putting a negative before the P to flip the sign. There we have it. Now, same thing. I know what that end result should be, 30,000, but what we could do is trial and error now. Like I could do that by hand. I could say, well, what if I change this to like 2,000 or like 2,500 and so on. And then we could use goal seek to do that for us. So that's what we'll do. So we'll go home tab, not home tab, data tab, forecast, what if, goal seek. What if like this number, we want this number to be 30,000 by changing that number, and then let Excel do the trial and error. And then we're going to say, okay, And so Excel does the trial and error. And then OK. So then if we go to the Home tab, add a couple decimals, so there it is. It kind of finds that really useful tool to have, because that allows you to basically see one formula in a similar way as you do with the algebra. If you know the algebra for one formula, you don't need to memorize a different formula. If another unknown is the unknown for that formula, you can use the same one and just solve for the unknown. You can do a similar thing here with the function, which could be quite useful. Let's look at it another way. This is probably a less common way to do this type of calculation, but you could do it this way as well. Another use of the goal seek, just to see how the application could play out. So if this is an annuity, we can also do our annuity running balance, right? The running balance 1, 2 on down, 1, 2 on down to 10. Center that, Home tab, alignment, and center that. Once again, the payment is what we don't know. We don't know what the payment is, so I'm just going to put 1,000 for our starting point. All other payments are going to be the same because it's an annuity. So I'm going to say this equals the 1,000, and I'll autofill that all the way down. Autofill. And then we'll do our present value calculations here on that 1,000. And then I'm just going to use the goal seek again at the end of the day to fix this 1,000 to get the end result, which will be down here, to the 30,000. So let's do this. We're going to say this will equal the present value of the rate, which is going to be, the rate is over here somewhere, 12%, comma, the number of periods, which is 10, comma, I'm sorry, hold on a second. The number of periods is 1, because this is 1 period out, comma, comma, future value 1,000. So we're breaking out the annuity into 10 present value of 1 calculations here. So then I'm going to say enter, and let's change the sign, double clicking on this, making this a negative. So that's going to be our starting point. And then second one, let's do it again, equals the present value. Present value rate is going to be the 12%, 12, comma, that's not a comma. And then the number of periods is going to be 2 now, because we're 2 periods out, we're present valuing, comma, comma, and then 1,000. I'm going to put a negative before the P to flip the sign. So there we have it. So that means the value at this point is the 893 plus the 797, and so on. So what I'm going to do now is try to copy this down. Before I do so, I got to make this number right there an absolute reference, so that it doesn't move when I copy it down. That's in cell S11. So S11, putting my cursor in S11, selecting F4 on the keyboard, putting a $sign before the S and the 11, telling Excel, don't move that down. This is an absolute reference. You only need a mixed reference, but I just use an absolute reference because that'll work, and it's easier for me to understand than trying to figure out which one doesn't need to move. So then I'm going to select these two and use autofill to drag them on down. So there we have it. Now this ending number, I know what that needs to be. That needs to be 30,000. So I could go back up here, and it all hinges on this number. This is a more complex series of network of numbers, but they're all tied together now. So I know this 1,000. What if I change that to 2,000? And so on. The end result's getting closer. What if I change it to 3,000? Then we can use goal seek to do that calculation here as well. We can then say, well, let's use the goal seek to do this kind of trial and error thing by going to data, forecast, what if, goal seek. And we want to then set this cell to be 30,000. And we want to do that by changing this cell. And then we'll say okay. And it does it for us automatically with the goal seek. So a really useful tool to have that goal seek, a really useful concept whenever you have an algebraic equation down here, to start thinking about the fact that if some other item is unknown, you can use the same algebra as long as you have one unknown, so you don't have to memorize a bunch of different formulas, and that same concept can work with Excel formulas up top, even though they're not algebra. You can't solve for them algebraically when there's some other unknown, but you can use the same concept in essence by using the goal seek feature.